I don't know what you're going to think about it all.
It's either like
We'll have to see.
it's either going to be like 5 bonus points or just like another test.
Another test would be diabolical.
If there's another test, I'm leaving. Like I'm actually just walking out.
All right.
Another test would be diabolical.
Yesterday,
Diabolical.
we got up to number 117 with fifth period, I believe.
They did not get that far.
What?
They were supposed to pick up where we left off.
Well, they were, but they did a lot of questions that you guys didn't cover, lower numbers. So you guys had left off.
I watched the video. So.
You guys left. Yeah, there's some good stuff on there that we didn't cover yesterday that I think would be good for you guys to watch. Yesterday we left off on 109, right?
Yes.
Yes.
Can we do 117?
Yeah.
I did 117
All right, 119.
yesterday.
I request 119.
So let's go to 119.
We also did
Maybe we
117.
did.
Yeah, we did.
We didn't.
Yeah, we did 117 yesterday.
I did 117 with fifth period.
Maybe the delusion that you're going to survive this
So what number are we doing?
on the 1030 is also.
Whoa, what is Megan going off about? Goodness. Megan, have you ever lost?
Guys, I can take the keys if I can.
All right,
You see who you are.
you wouldn't be in the kitchen. I like that.
I don't like.
Oh my gosh, getting none of these right. I've gotten 3 right, Mr. Heller.
On
3.
On physics or chemistry?
Chemistry.
119.
Moving forward.
119. Calculate the pH of each of the following solutions. 0.10 molar CH3NH3Cl. So first of all, is that an acid or a base? We have to kind of figure this out.
Looks like a base.
So what I would do is I would take this
Looks pretty basic.
CH3
No way that's an acid.
NH3Cl, and I would see what I can break that up into, right? So I can break that up into
CH3NH3 plus.
CH3 NH3 plus Cl minus. Now do I have an acid?
Yeah.
Because the Cl minus does not act as anything. It's just.
That's an acid though, right?
Yes, that is. The Cl minus doesn't do anything.
Correct.
Okay.
You got it.
And it's just a yield, not an equilibrium.
And we know, because this is just breaking up, and we know if because Cl doesn't have, it's an ion, right? This has no acid or basic properties. Agreed? So I can take my CH3 NH3 plus, and that would be in equilibrium with CH3 NH2, right? Plus what? Plus H plus. Plus H plus. I could write a Ka for that, right? If I were to write my Ka expression, Ka would equal what?
Concentration of H plus.
Concentration of CH3 NH2 times the concentration of H plus over the concentration of CH3 NH3 plus.
Are we allowed to use the shortcut on the test?
The shortcut?
Yeah.
Sure,
Give me.
you can. So, what do I have here? Do I have a lot of stuff from this? What can I sub in here? What would you do next?
Probably look up the K value.
Yeah.
Of what?
CH3NH3
And what did you get?
Oh wait, no, I found the KB value of CH3 and H2, and then I just transferred it over to the Ka. I did the equation.
Like the 1.0 times 10.
Yeah, that one.
Yeah.
Okay, what'd you get for the KB?
KB had 5.6 times 10 to the negative 4. For CH3 and H2 plus. Or no, CH3 and H2. Wait, am I on crack? Yeah, no, I'm right. CH3 and H2, the KB is 5.6 times 10 to the negative 4, and then for the Ka for CH3
I
and
have
H2 plus
4.38
is
times 10 and then I
Ka.
get a 4.
But I don't need KAs here.
Wait, what?
I don't need KAs, I need concentrations. Agreed?
Well,
I'm trying to figure out. On 119, all I have is concentration.
Yes, and we only have the concentration of the
And I only have the concentration of what?
NH3 plus.
Of the NH3 plus.
Yes.
Now what?
Ice table? I don't know.
Ice table?
I don't know.
Bro, I just did the pH equals, I just did the shortcut for chili. Yeah.
And what did you get for your answer?
I'm being chilly.
What'd you get for your pH?
Yeah, the pH I had 5.87.
5.87?
Yeah.
That's pretty close. It's actually pretty close.
Bro, I'm
We
actually,
did the shortcut.
yeah, the shortcut. I already know. Wait, should I just like write it on the board? Like, I don't know.
No, so
I'm not trying to explain all this.
if I take my, so out of this, right? If I decide to rice this thing, let's rice it. So if I have CH3, NH3 plus is in equilibrium with CH3, NH2 plus H plus. Initial concentration is 0.10 molar, right? 0, basically 0. Change is minus X plus X plus X, E 0.10 minus X, X, and X. So, my Ka, what is my Ka?
It doesn't give it to us, you have to look it up.
What did you get for that?
KA, hold on.
That's what I'm trying to get you guys to figure out here.
I had the KA value as 2.28 times 10 to the negative 11.
Yep. So 2.28 times 10 to the negative 11th.
Wait, how'd you find that though? Google. Someone did.
You just look it up.
I'll make sure to do that on the test.
I'll give you all the K's you need on the test. Okay? Is X squared over 0.10. Right?
I'm pretty sure you could have also found the KBs.
You could have done that too. So I solve for X, and X ends up being 1.5 times 10 to the negative 6 molar. Take a P, so the negative log of 1.5 times 10 to the negative 6 equals 5.82. So Jawi, you were pretty close. 5.87, that would work.
Let's go.
That would work. So that's 119A. For B, I have NaCN, right? So I have NaCN. That's going to break up into Na plus Cn minus. Does Na have any acidic or basic properties?
It does literally nothing.
It's an ion, right? Could Cn do something?
Oh, there's cyanic acid.
Would Cn be a base or an acid?
D,
Be a base, right? So if I wrote an equation for Cn minus, what would I add to that? Water plus H2O would give me HCN plus what? OH minus. HCN plus OH minus. So, initial for my CN is, they gave me 0.05 molar. Water's not part of it. 0, 0. Change, minus X, not part of it. Plus X, plus X. Equilibrium, 0.05 minus X, not part of it. X and X. My KB. Did you look this one up, Megan?
This one was in the book.
Okay.
But, yeah.
And what did you get?
That's the wrong thing. 119, I got Ka to be 6.2 times 10 to the negative 10.
What about the KB? We're looking at the KB.
Oh, KB, 1.61 times 10 to the negative 5th.
Yep. So 1.6 times 10 to the negative 5th equals X squared over 0.05.
I accidentally used Ka after that first.
So X equals 8.9 times 10 to the negative 4th molar. Take the negative log of 8.9 times 10 to the negative 4th, and you get 3.05, which is my POH, right? So subtract 14 from that, and you get 10.95, which is your pH.
This might be a very random question, but we use Kb when there's an OH minus on, for a product and Ka when there's
You got it.
Okay, sweet.
Yep.
I have a question about the review sheet. 13 through 18 are like the thing that talks about like the Bronsted, like Lowry acid, like,
Oh.
did we go over that?
Wait.
We talked, that's the very beginning of the notes, because Bronsted Lowry acid or a Lewis acid, they're just the different definitions. So one of those talks about being a proton acceptor, and one of them talks about being, I can't remember, I don't want to see right now, but it's like the first page of the notes.
I think it's Bronsted, Lowry, and Arrhenius.
And Arrhenius,
And then like
correct.
proton acceptor donator, and then one disassociates to produce hydroxide, and then one disassociates to produce H plus.
Yep.
I want to say that's Arrhenius, the one that's disassociated. and
So that's
Bronsted-
straight out of the notes.
Bronsted, Lowry.
Yep.
Can we do 137?
Anything? Oh yeah, that'd be the next one.
Yes.
All right, let me make sure I didn't do that one yesterday. I did not.
I swear there's like.
All right, chat.
Is this real chat? Chat, is this real?
137.
Chat or betting?
Guys, I could not get out of bed this morning. Like, I had a hard time.
You need to motivate yourself.
I got out of bed at 6:52.
I got out of bed at 7:35.
Well, I have to be here by 7:15, so.
I got it.
All right, 137A. 137A. A Lewis base, let's define it, is what? It's an electron pair donor. That's what a Lewis base is. A Lewis acid is an electron pair acceptor. That is straight out of the notes. So, on letter A, what is my Lewis acid? Which one is going to accept a pair of electrons?
Is that just referring to the same thing as like is that equivalent to accepting a hydrogen or is this something different?
Pretty much. Because a hydrogen would be a pair of electrons.
Wait, no, if Lewis acid is accepting electrons and it's giving away.
I'm sorry, Lewis acid is an electron pair acceptor, right?
Yes.
So it wants to gain an H, because that would be a pair of electrons.
An acid.
Oh wait, sorry. It wants to accept a pair of electrons. Sorry. I'm not trying to confuse you.
That almost killed me. That almost would have been the end of my right then and there.
So, BOH3 or H2O? Which one is your electron pair acceptor? On the left. You got it.
That's the acid then?
Yeah, you got it. So BOH3
You're selling me right now.
is the acid. Therefore, H2O has to be my what? Base. Do I care about stuff on the other side? No, that's the conjugates. Letter B. Ag plus. Is Ag plus going to be my acid of the base?
No. I don't know. It has a proton, but we're not talking about those.
Talking about electron pairs.
It's gonna be the acid.
It's the acid. Ag plus is the acid,
Explain.
and NH3 is the base. Because Ag plus is going to be the electron pair acceptor.
Why?
Look at the other side, right? Ag added something. You're adding something to your Ag.
Wait, but couldn't it also be added to the NH?
No.
Why?
Look at the first one, right? H2O. Your BOH3 became your BOH4.
Yeah.
So on this one, the Ag is accepting. It's basically whatever is accepting something. Let's do C. It'll make more sense when we do C. Letter C, which one is my acid? Which one gains something? The BF3. Yeah.
Oh, because it became BF4.
Yes, you got it. BF3 is my Lewis acid. Therefore, F minus is my what? Yes.
But I feel like it also applies to
Essentially, find out what your acid is, and the other one's the base.
Didn't the F minus become BF4? I don't see that.
It's like the exact opposite of it.
What is the opposite?
H plus is not a base, it's an acid.
Right?
I'll reveal.
Stop.
That's 137. Next one. I know what you're gonna ask for next.
144.
144?
144D.
Just do one.
144. 144.
Right now.
I can do this.
Which of the following represent conjugate acid-base pairs? So, letter A, H2O and OH minus. So, OH minus means it,
144.
H2O did what with a proton? It donated a proton, right?
Yeah.
So is that an acid-base conjugate pair? Yeah,
Oh, it is?
it is, right? B, H2SO4 and SO42 minus. Yes or no? No. Why?
Because that's diproduct. And also the SO4 minus 2 would have to gain 2 hydrogens.
H2SO4. How many protons can it give away at a time? Only one. So what is my actual conjugate base going to be? HSO4 minus. You can only give away one H at a time. You can only give away one H at a time. Letter C. H3PO4, H2PO4 minus. Yes. Letter D. HC2H3O2, C2H3O2 minus.
Checks out.
Yeah.
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 Let's go.
It's a difference of one hydrogen. Yes. That's a conjugate acid-base pair. It's 144. Next one.
23 on chapter 2.
150.
159. That's the next one I heard.
Wait, no, 155B.
155B.
Yeah.
Okay. Do that. So 155B.
There's no way, and there is no universe where that's not what we have. Yeah, this one killed me.
Why did this kill you? Isn't this just counting? So, this picture, the following illustration displays the relative number of species when an acid HA is added to water. A, is HA a weak or strong acid? How can you tell? Let's do A first. Might as well. Weak. Why?
It's barely dissociated. Yeah.
Yeah, because there's only one set of H plus and A minus absent, right? So most of it stuck together. B, this means that there's one set that broke up. Agreed?
Yep.
Out of how many? Yes, I can.
Like 10?
One set out of 10. Agreed? So this is equal to 10%.
Oh.
Agreed?
I was overthinking this.
Are you okay with me so far?
Is that for percent dissociation?
Well, 155 is not asking for, oh yes, that's percent dissociation. So that's percent dissociation. Well, 1 divided by 10 times 100 would be 10%.
The only answer in the book is 2.2 times 10 to the negative third.
Well, that's because they forgot.
That's the Ka. They didn't do the percent dissociation. Right? Percent dissociation is 1/10. Right? So, to get your Ka, I have HA. Here's my reaction. Is going to be in equilibrium with H plus A minus. There's my R. Initial concentration is what?
That's 0.2.
0.20 molar. 0, 0, change, minus X, right? Plus X, E, 0.2, ooh boy, 0.2 minus X, X, and X. So, this means that Ka is going to equal, I know.
Our numbers down, we're way down in every class.
Yeah, I don't, what is going on today? Like, where is everybody?
Where is it?
Velma's at a doctor's appointment.
Lots of doctor's appointments apparently.
You know,
I
Dr. Make
lost
it
one kid's first period. They were just not. 4 showed up.
Joe, it hit me something funny.
What?
Maggie must be sick.
Anything funny right now. It's terrible.
Huh?
Have you been following the text feed?
What do you mean? Bro's not
Very
not
common
that
today.
anymore.
I'm very behind. I'll have to check. So,
We're losing.
Ka equals x squared over 0.2. Agreed? Yes? Now, how am I going to get this?
Wait, is H plus, there's one H plus. I don't, the entire thing.
I'm asking you guys.
What was that? And it,
Like 2 mole. Oh no.
What would you do here? Because I got two unknowns, which means I can figure out one of these.
I'm guessing that we're supposed to figure out the H plus when
Uh-huh.
we're solving for the K, but other than that, I don't have any.
We know that the concentration of H plus is going to equal the concentration of A minus. Agreed? Yes?
Yeah,
Which is equal to X. Yes?
correct.
You guys okay with that?
Correct statements.
Which is going to be equal to what? Well, I started out with what molarity? 0.20 molar. And what percent dissociated?
10%.
So could I just multiply that by 0.1? Would that work?
Yo, that's crazy. Wait, that actually works though.
So that means X is equal to 0.020 molar. Yes? Which means I literally have all of these numbers now. So I'm going to have Ka equals 0.020 molar divided by 0.2 minus 0.02, because we can sub it in or just leave it. It doesn't matter. The 5% rule would work. But let's do it. So it's going to be 0.020 molar squared. Well, I just did it. 0.2 minus X.
Oh,
Right? You could do it and you're going to get the same, essentially the same answer. So you had to do a little bit of reasoning there to figure out what X is. Because X is going to be 1/10, right? We know only 1/10 created.
Overthought.
So Ka, when you do that math, ends up being 2.2 times 10 to the negative third.
Do the book really just forget to put percent disassociation in it?
Yeah. It's 10%.
That seems high for like how much. Just
Usually it's smaller, but that's just what.
159B.
After 155. 159B. Yes? Are you okay with that?
I'm sorry for that.
All right. 159B. 159B. Okay, on 159, I've got this iron H2O stuff. Iron H2O stuff, which is kind of weird, but that's fine. So, on A, did you get your pH?
Yep.
What'd you get?
1.61.
1.6, yes, that's good. B, will a 1 molar solution of iron 2 nitrate have a higher or lower pH than a 1 molar solution of iron 2 nitrate? So once again, will a 1 molar solution of iron 2 nitrate, wait a second.
I think it's iron 3 nitrate.
Oh yeah, sorry, have a higher or lower pH than iron 3 nitrate? Well, you guys tell me. Has something to do with the charge, right?
Yes.
That's the only thing that's different. So how would we explain this?
I think the iron
What do you guys think? Which one is going to be less acidic?
less acidic. The iron plus 2 probably.
Why?
Less
That's a great question.
plus. There's less plus charge on it.
That's a great question.
So, because
Is it F plus 2?
of the lower charge, Fe2 plus is a weaker acid, which means, so therefore, a solution of iron 2 nitrate will have what type of pH? Yes, have a higher pH. How do I know it's a weaker acid with a lower charge? Why?
Because it's iron 2 and not 3.
Yeah, but why? How do I know that?
Oh, less protons do, I guess. No, that doesn't make sense.
It's Coulomb's law. Right? I have only 2 ions here. Agreed?
Yep.
How many ions do I have in with the Fe3 plus? 3. This is essentially Coulomb's law.
What's Coulomb's law?
Well, Coulomb's law is size and charge, right?
Wait, so there's more charge than this peak.
We
Wait,
just did this in the
that's
quiz.
what work. Never
So, Fe2 plus, there has 1 less ion. Therefore, there is weaker attractions,
So I just looked at over
right?
D squared, like,
Weaker acid.
Q2 over D squared.
So, that's just Coulomb's law. That's 159b. Next one. Chapter 15.
21.
Okay. Chapter 15. Number 21. All right, let me get to number 21. What page is that? 639. Chapter 15 is a pretty short chapter. And what?
I said it's short, but it's good.
Is this the one with pictures? Yeah. This one on purpose. So I have 3 pictures. How many of the following are buffers? Well, what is a buffer?
Neutralized acid base.
It mops up additional H plus or OH minus to minimize changes in pH in a solution.
It's a weak acid and it's conjugate base, right?
Yes, it could be a
Or a weak base,
conjugate acid,
it's conjugate acid.
which, minimizes changes in pH.
Correct.
Because it
Correct.
reacts with the H plus and
Correct.
OH minus.
Yes. But all we have here is just pictures. Beaker A is what?
Strong,
Strong acid or strong base?
strong acid.
Just tell me.
It shows there's a key that has H plus.
Oh, there we go. Beaker A is strong acid.
Strong acid, because it's all completely just,
Beaker B. I'm talking about the second beaker at the top.
very weak base. Wait, no,
Is I have H plus
it's very weak.
and I have
It's a weak
matched up with B minus. Mostly together, agreed?
one, and it's very weak.
Weak base. Beaker C
Wait, is it base or acid?
on beaker B.
Yeah, it's base.
Well, if it's an H plus with a B minus.
The B for green, okay, I just thought it.
Beaker C, I have B minus with H plus, and I also have the A minus, the salt. Right?
What are you on about?
Oh, guys, I'm colorblind. I'm so sorry.
Oh, okay.
I have the H plus,
You have the HB and the H plus and the B.
I have the H plus and the B minus, and I also have what by itself?
HB, like we have the actual acid.
I have the B minus by itself. So I have the acid and and its salt.
That was the base.
So beaker C. Beaker C.
Is it an acid or everyone is?
Wait, so why is it beaker C?
Well, because beaker C is the only one that has H and B minus, and also has the B minus floating by itself, right? So that is, you have to have both the weak acid and its salt, or the weak base and its salt. It doesn't really matter if it's an acid or a base, but you can see that that's the only one that has the salt in there with it. So that's 21. Next one. 23. 23. A certain buffer is made by dissolving NaHCO3 and N2CO. Write equations to show how this buffer neutralizes H plus and OH. Okay. So let's do H plus first. H plus is going to interact with what? What is going to be able to take up the H plus in both of these? CO3 2 minus, right? That's going to be the ion that's going to eat up my H plus. Yes? What is that going to make?
HCO3.
That's going to make HCO3 minus. And what is the So that is one thing you could write. What about my OH minus? The OH minus is going to react with what? Plus the HCO3 minus, right? Because that's going to make what? CO3 2 minus plus water. So this one eats OH minus, and this one eats H plus. That shows how one can eat OH minus, one can eat H plus.
That's supposed to be swapped.
What?
It's like the one that has the hydrogen reacting says it eats O minus.
This one?
Yes.
Well, this H plus would eat an OH minus, right?
Yes. But I thought that was taking up. If it's reacting with the H plus, how is it not eating the H plus?
Flip that.
Okay.
There we go. Flip that. But it shows that there's an equation that can eat both of them.
Yeah.
That's what matters. That's 23.
Work together.
They do work together.
25.
Oh my gosh.
Bro, no, 25 is super long.
Oh god, no,
Good,
fine.
good, good. Make fifth period.
Like,
Can I save that for 5th period?
Yeah.
Sure, I'll just watch it later.
All right,
Okay.
29.
All right.
That is just as long.
No, it's not.
Yes, it is.
29 is not as long.
Maybe I made it. I bet you did. There's multiple
Calculate the pH.
of each of the 4 solutions.
Oh,
Let's
I'm
just do C and D. That's the only ones I don't know how to do. C and D.
I didn't read the question.
Yo.
Well, they're all kind of the same.
This one killed me. I don't know.
I just need C and D. That's the only two I don't do.
That's the only two you don't know how to do.
Unless I got A and B wrong.
I think it.
Also, it could be a possible.
So what is this based off of?
It's based off 25.
This is based off of 25, right?
Yes.
So 25 for 29. 29C. 29B?
Yes.
Sure.
Did you get 5.1?
On 29B,
No, I got 5.5.
I got 5.49.
Close enough.
No, it's not.
No, it's not.
5.1 and 5.49 are not enough.
I heard it differently.
29B is based off of 25B, right? 25B, what is the ion that I care about?
The acetate.
C3H5O2 minus.
Acetate.
No. That'd be C2H3O2.
Carbonyl.
So my R is C3H5O2 minus plus, I'm going to be adding H plus to that, is in equilibrium with HC3H5O2. There's my R. Initial. I have 0.10 molar of this. Agreed? What do I have for my, do I have any H plus to start with? I do. Right? From 29, I have 0.02 moles in 1 liter. So I have 0.02 molar of this, and I don't have any of the acid yet. So, change
How do we get H plus
from 29.
Yeah, how do we get, like, what are the
That's what I added,
0.02?
because I added it. What's my minus here? What's my limiting reactant?
Oh, the 0.02.
So, minus 0.02, minus 0.02, plus 0.02. So my equilibrium is 0.08, 0, 0.02. Is this a buffer? Is B a buffer? NaC3H5O2 and HCl. That's a buffer, right? So how am I going to get the pH? Henderson-Hasselbalch.
Okay, what's
pH equals pKa plus log of my base, concentration of the base, over the concentration of the acid. So pH equals, for my Ka,
is the base the same as the salt in this?
what?
Concentration of the base, is that referring to the salt in the equation?
Yes, that's the salt. So my Ka is going to be 1.3 times 10 negative fifth. So I'm going to take the negative log of that. So the negative log of 1.3 times 10 to the negative fifth. That gives me 4.89 plus log of 0.08 divided by 0.02. So pH equals 5.49. pH equals 5.49.
And when it says acid, that's the HC3H5O2 on the right? The
Mhm.
concentration of the acid.
Correct. C is pure H2O. Agreed?
So it's just,
So this is just a strong acid problem. Agreed? Am I going to get anything from the water? So I'm literally just going to take the negative log of 0.020 molar. Agreed?
yes.
So that gives me 1.70. You still have time? You want a D, right, Jack? D. I'm trying to think of that verb. I'm going to split the page. So for letter D, my added H is going to react with whatever base is present, right? So my base,
In the original one, there were two things in 25B. In 25B, there were two things in there. I think it was sodium carbonate and the acid.
right, but it's really only going to react with the best base present, right? So I'm just going to say, like, I don't know. We can make up some kind of letters here. Let's say, I don't know, B minus plus H plus makes what? Essentially BH, right? So my B minus, they're both what? I'm not making them numbers. Because it doesn't really matter, because these, one's HONH2, one's HONH3Cl, they're both the same. It doesn't matter which one because they're both the same. So my B minus before is going to be 0.100 molar for my initial. My H plus is still 0.02 molar. I don't have any of the combined. Change, minus 0.02, minus 0.02, plus 0.02, equilibrium 0.08, 0, 0.02. Henderson-Hasselbalch.
Is that the same thing? B?
Pretty much.
They were different answers.
Well, it's not exactly the same because now I'm going to be flipping the 0.8 and the 0.02, right? So at the 0.08, at the 0.02 on B, I had, and on this one, I think it's also a different pK.
It's the same.
Is it the same?
Yeah, it's the same pK.
0.08, 1, 2.
The book had the answers 4.71.
So I have. Oh wait. It has to be. I actually do start out with 0.100 molar here. That's the difference here, because I have both.
You have the acid already, just because you have
Yes.
the acid already to start
So this isn't. This is 0.120 molar.
with. Okay, because we started with one acid and we added a second.
Correct. So we had both of them present. So now I do my Henderson-Hasselbalch. pH equals still 4.89 plus. Is this pen gonna die now? Did this happen in this period or last period yesterday?
Last period.
Oh my gosh. I don't know how all my pens are dying.
Is it 4.89?
It's still 4.89. So 4.89, come on, plus log of 0.080 divided by 0.120. So that equals 4.71. I knew it shouldn't be the same.
Oh, and that looks like, yeah,
What number was that?
that was 29.
That was 29. 31, what's 31?
That's 31.
Just another one.
31 is kind of the same thing, but with a base. So I can save that for
Yeah, 'cause
fifth.
it's not.
Good work, team. Tonight is major locking.
Tonight's, yeah, tonight is.
Tonight is where you find out if you have